Ransom Griffith's occasional series of YouTube tutorials featuring Matlab. Today we're doing Euler's method in Matlab. Now I assume you have a reasonable idea of what's going on. I'm not doing it from absolute scratch. So we have here the function there, the ODE, first order ODE. There's from first principles, the limit of delta t, etc. I'm not going through that. And easily rearranging down here, yn plus 1. The next one is the yn by the delta t, the time interval, by whatever the function is at that particular period. So I assume you have a fair idea of what that is. So we get the next step by looking at the previous step plus the delta t, the time interval, by whatever the function is at yn. We're going to look at this example. We're going to solve this lad. dy dt is 1 minus t times y. And if we go through it step by step by step by step, the exact solution is given here. Y equals e to the t minus t squared over 2. And we're going to compare that method with the approximate method that we're going to do in Matlab. Okay. So I have it here. This is for my students. Just I've broken it up into sections with the double percent. The student can put in the appropriate ones there. Tidy up here another section. Just be careful here when you're doing sections. Just be careful that there's a space between the second percent and that. Another section here. There we go. I've just put in a comment. That's what we're trying to solve. The delta t is 0.1 of a second. If you want for more accurate answers, you might make that 0.005 or something like that. The time interval that I'm going to solve it over is from 0 seconds to 5 seconds in steps of 0.1. So that's what 51 I think it is, or whatever it is, or 61. Intervals. I initialize y, that's going to be my approximate answer to whatever that is, 0 to 5 in steps of 0.1. There's my initial condition. I have a little for loop here. So my next one, my yi plus 1, or my yii is my previous one, plus the delta t by, just go back here, by whatever that is, by whatever the function is at yn tn. And the function at yn tn is 1 minus t by yii. So that's, I can't say it anymore. You loop around there, you go around whatever it is, 50 or 60 times. So y will contain the approximate answer. There's the exact one. Then I did a plot, a dual plot. So plot x comma y, so that would be these two here. They'd be the approximate ones. These two here are the exact ones. This line here, line 22, put on a title. X3 put on a label, an X label. Y line 24 put on a Y label, and then put on a legend. So go back to the editor, run that. There we are. Just the title, just a little question mark came up, but bar that, everything's fairly decent. And I got my legend to work at approximate and exact. Hope that helps a little, and thanks very much for listening.